everybody, welcome to my channel. Today we're gonna discuss about genotype analysis by mixed effect using alpha lattice design, and we will consider genotype as well as a block within replicates as a random effect. And again, we will use the methane package with respect to this data, and our data is data underscore alpha. So let's submit the package. Then again, let's see our data. So as you can see here, there are 5 columns. And the first column shows the plot number. It is not our target and it's not important as such. Then the second column is replication, followed by block, followed by genotype, and lastly is the response variable or the grain yield. So starting from column 2 with column 2, 3, 4, it is our factor, and we will consider the genotype as a random effect, as well as blocks within the replicate will be the second factor, and the response variable is the yield. Then we will use the function, the GAMEM, which helps us to create random model, especially in a methane package. Then first you have to indicate your data name. So in our case, our data name is data underscore alpha, and the design is alpha lattice design, and followed by genotype. Gen means it is an abbreviation for the column that contains the genotype. So when we see from our data, so gen represents the genotype, then followed by the replication. So replication is a column that contains replication, and REP is which is found here in this form. Maybe for you it's replication or replications, whatever it is. So you have to assign in that way. Then block is equals to block. So when we are just assigning here is a block, you are telling to R the design is alpha lattice design. But if you remember in a previous tutorial, we just nullifying this section, or we omitted totally. So if you are not considering the block is equals to block, or if you are not showing or telling to R to do these tasks, it understands that you are using randomized complete block design. Then lastly, it is followed by the response variable. So in our case, the response variable RESV stands for the response variable. So in our case, the response variable is yield, as you can see here. So maybe for you HM, YD, whatever it is. So write this one and submit to our studio. Yeah. Then we represent all these codes. I mean this code into what? Into A. Then submit to our studio. Then here is we get the p-value on the base of likelihood ratio test for the grain yield, and as you can see here, the p-value is 0.0018, again 0.0035, which is less than 0.05, and all variables are what? The significant effect, and the model here is the genotype and block with replicate are statistically significant. Then go for finding of genetic parameters, finding of random effect, again find for variance component. So in order to do that, you have to use the shortcut. That means get underscore model underscore data, and A means the that means A means what we consider in genotype as random effect, and block with replicate as random effect. So we represent all this code into A. So A means this one, then a genpar, which is stands for the genetic parameters. So type this and submit to our studio, then you'll get all the genetic parameters. Yeah, here is the grain yield, and here is the genetic variation, heritability, phenotypic variation, whatever you want. So in the previous of one of my tutorial, I already explained all these parameters. So if you want to understand more, you can trace back one of my tutorial regarding to this definition. And moreover, you can get also the random effect. All things are similar. You can use the get underscore model underscore data, then then run EF means you are telling to R to display the random effect. So type this and submit to R Studio, then you will get all the random effect in your model. And lastly, if you want to see the variance component of the model that you created, remember our model is a mixed model and we are considering genotype as well as the blocks will replicate as random effects, then get underscore model underscore data, then then vcomp. Vcomp stands for the variance component, so R will display you when you submit this to RStudio. So this is all about alpha lattice design whenever you want to carry out a mixed model by considering genotype and block within a replicate as a random effect. So this is today's tutorial, and as usual, if you have any question regarding to my tutorial, you can address me through my email workdratasforum@gmail.com, or alternatively you can put your suggestion, comment, whatever it is, into YouTube comment box. Thank you for watching. Have a nice time.